Okay, so we talked already about something called the circumcenter of the triangle, which is found when we draw the perpendicular bisectors of all three sides, and it's the point where all three of the perpendicular bisectors meet. Now we're going to talk about a different important point in a triangle, which is called the incenter of the triangle. The incenter of the triangle is the point that results when we draw the angle bisectors of all three sides of the triangle. I'm going to construct those angle bisectors for triangle ABC here. There's the bisector for angle A. There's the bisector for angle C. And now the bisector for angle B. And this point then is the incenter of the triangle. Now, since any point on a perpendicular bisector is since any point on the angle bisector is equidistant from the sides of the angle, then this point is equidistant from all three sides of the triangle, and that's the key idea behind the incenter of the triangle. Notice that one other thing that we'll say about it here before we move over to the theorem is that that incenter is always on the inside of the triangle. Even if the triangle's obtuse or right, the incenter is always on the inside of the triangle, where if you'll recall, the circumcenter of an obtuse triangle was actually on the outside of the triangle. And so that's our incenter. So let's move over and look at the Incenter Theorem. The Incenter Theorem says that the angle bisectors of a triangle intersect at a point called the incenter that is equidistant from the sides of the triangle. So if I tell you that point P is the incenter of this triangle, then what you know that the distance from point P to all three sides is the same. The distance from point P to each side is the length of that perpendicular segment. So that means if P is the incenter, then segment PD, segment PE, and segment PF must all be congruent to each other or equal in length.